Afternoon, evening, and welcome to our third series of oil and gas related webinars from Endress Hauser, focused on the oil and gas and petrochemical applications. Today we will discuss large size flow meters and how they can get the highest accuracy and performance. And the speaker of today is Alp Camci. Alp works in our solution department in our Instrument International division, and he is located in Rheinach in Switzerland. This webinar will last roughly about 45 minutes, 30 minutes presentation, and 15 minutes question and answer. In oil and gas, it's very common to have a small safety moment before we start any activity. And today I would like to focus on the current COVID-19 situation. So please wash your hands on a regular basis, keep at least 6 feet or 1.5 meters distance from each other, wear a mask in public, get vaccinated when you get the opportunity, and make sure that you stay in good mental health as well. My name is Rob Vermeulen, and I'm globally responsible for the development of the oil and gas industry for Endress Hauser. I reside on a campus in Greenwood, Indiana, in America. Good, but before we start, I like to do a small introduction in the agenda for today's event. Here you see the agenda in front of you. So the topic of today, the speaker, we did that, and then we have the question and answer. So then the slide for with regards to the introduction of Endress Hauser. So here you see the place actually where Alp is residing on the picture on the top. Endress Hauser is a global leader in measurement instrumentation services and solutions for industrial process engineering. So we focus on instrument and solutions and the services around it. We're active in a lot of industries, and if you look at our figures, we're a roughly $2.6 billion company. We employ 14,300 employees, own employees worldwide, and we have over 8,000 patents as well. So we're very innovative and financially solid. So with this is a very short introduction of Endress Hauser. I'd like to hand over to Alp so he can introduce himself and the topic of today. Go ahead, Alp.
Hello, good day, ladies and gentlemen. Good afternoon, morning, or evening, wherever you're located around the world. Yes, my name is Alp Camci, and I am working, as Rob said, in the headquarters located in Rheinach, Switzerland. I am the head of applications for business unit solutions and responsible for the regions Europe, Central Asia, and Africa. I am working for Endress Hauser for 15 years and 10 plus years already in the project management and engineering of flow metering systems in oil and gas industry. How Endress Hauser is known today in the oil and gas industry. Endress Hauser for years has been considered as an excellent supplier for reliable instrumentation for the market. But today I will try to show you some examples and give you a picture that Endress Hauser is not only an instrument supplier, but much more than an instrument supplier. We can supply flow metering systems for the oil and gas industry. We have the capabilities, know-how, and the structure to be an active partner in execution of turnkey custody transfer flow measurement solutions. And I will, during the course of this presentation, I will not just say things, but I would like to show you things like an example you see in the on the left-hand side of the screen, which is a locked unit which is manufactured by Endress Hauser. What are we going to cover today? I would start with some basics like what custody transfer means, what are the applicable standards worldwide, why accurate measurement is important in flow metering systems. Then I will go to the solution of the Endress Hauser for the accuracy, which is Coriolis flow meters, discuss a little bit of benefits and difficulties of Coriolis flow meters, Endress Hauser specific solutions for these difficulties, and I will then show you real turnkey custody transfer meter solution examples. Custody transfer, it is a very well-known word, but I think we can spend 1 minute what it actually means. Custody means the ownership. In our case, the ownership of oil and gas. And the transfer is the point that this ownership is changing. Everybody who is familiar with the project management will say that the change of ownership is a very important milestone in the projects, and it generally is associated with a payment. At that point, when the payment has been agreed, the seller and the buyer both need to know accurately how much oil has been transferred, how much oil has been flowed. This is a very much regulated area of the measurement, and we have international standards covering this measurement section. The most known international standards is the API, American Petroleum Institute Manual of Petroleum Measurement Standards, worldwide known as PMS, or for the European market, it is the OML, which is International Organization of Legal Metrology. Normally, countries do have their own standards, but if they are lacking the standards, they will adopt either MPMS or OML, depending on the geographical region. But of course, as it is related to payments, and all payments are related to taxation, local regulations take place, and they are precedent over the adopted standards. When it comes to errors in custody transfer applications, there is no worldwide agreement on measurement errors. API does not state a figure for the measurement error. The European OEML R117 measurement of liquids other than water is the only standard which specifies a target accuracy class for different metering applications like class 3.5, 0.5, 1. For example, the class 0.3 is for pipeline metering, 0.5 for track loading or big or beer measurement, or 1% for PG and such the other applications. And these numbers define the maximum permissible errors. Here, why reducing measurement error is important, I will give you a real life calculation here. So a typical pipeline of 6-inch, if you measure a conventional accuracy, say 0.5%, you are not sure about 400 barrels per day of the measurement if you are buying more or less, or if you are paying more or less. If you consider the 1 barrel of oil is $50 per barrel, at around today approximately, then you are unsure about $20,000 per day if your payment is correct or if you pay the correct amount. If you see it over a year, it is almost higher than $7 million per year. Let's put this 0.5% in a little stress test. So the best accuracy class as per MID, it is a European Union regulation, represent a maximum permissible error of 0.3%, then less than that 0.5. Then we are the number we are unsure about is drop of $4.8 million. What if we can do better? That Endress Hauser has reached and verified with small volume piston provers with a fiscal reference, I will say 0.15%. That error is dropping to 2.4 million. Then it is almost, we are saving, we are sure about $5 million per year, but there's a fair payment. And with this $5 million, you can even afford this car and put the gasoline inside that it needs to run. For reducing the measurement errors, the Endress Hauser, the product is the Coriolis Meter. And what is special in the Coriolis meters? What is their advantages? So, a Coriolis meter, in advantage on the system, on the left-hand side, you see a Promas X, the biggest available Coriolis meter in the market. The advantage is that this meter does not need compensation, pressure and temperature. It is direct mass metering, and the final amount is not affected by the pressure changes or by the temperature changes. The meter doesn't have any moving parts inside, so there is no wear and tear inside the meter. It needs less recalibration. It needs less recalibration and less maintenance, therefore it gives a higher availability. It does the job it is supposed to do in longer times. There is no shutdowns for maintenance and such. The meter is easy to install. It can even hold on the piping without supports. It has a compact footprint for the ease of the installation. As I said, it doesn't have mechanical parts, moving parts inside. Maintenance, therefore the maintenance needs to reduce to zero. It is just a pipeline if you consider it like it is, and there is no need to make filtration that you don't damage gaskets or blades or anything else for the measurement accuracy. It gives you a kind of process transparency because it is direct density measurement. It is directly measuring the density. And last but not least, due to the diagnostic technology Endress Hauser developed and implemented on the meters, the heartbeat technology, you can make your preventive maintenance because the meter will tell about his health status during the operation without interrupting the operation, and then you can make preventive maintenance plan and you can avoid the unexpected shutdowns. Does Coriolis meters have difficult mediums when they're making the measurement? Yes, we have to touch these points also. One difficulty is the entrained gas. The normatives and also the meter technology says the measurement should be in single phase. It should be either liquid or gas. When there is entrained air and trapped air inside the liquid, the oscillation frequency of the bubbles or the air molecules is different from the liquid molecules, and then this will create an error in the measurement. Second, the air bubbles will not equally distribute between the two tubes available in the Coriolis meter. This will create an additional measurement error. And due to the pressure change inside the meter, the bubbles will get bigger in size. The size of the bubbles will change and it will also create a measurement error. The second difficulty is related to the flow regime. So flow can be classified into two ways. It is either a turbulent flow or laminar flow, and there is a transition phase in between. When the flow is turbulent, the Coriolis force created by the liquid itself is perfectly observed in the outer wall of the measuring tube. Then you can accurately measure the Coriolis force, and then you can convert this to the direct mass measurement. When the liquid viscosity increases, the liquid will tend to have a laminar flow, which is shown on the right-hand side of the screen. Therefore, you can see the flow is muchly focused on the center line of the pipe, and there is some swirling effects on the pipe walls. Then the Coriolis force is that should be created by the liquid is sensed less on the outer tube, and this will lead to decrease in flow measurement. How Endress Hauser approached these difficulties and what is special in Endress Hauser Coriolis meters. The first is the entrained air. Endress Hauser has a patented multi-frequency technology. By years of studying the effects of air inside for the Coriolis effect or on the vibrating environment, Endress Hauser developed a patented algorithm that the Coriolis meters is operating in two different frequencies, and we know the effect of this frequency change, how air is moving in these two different frequencies, and we can make active compensation inside the electronics of the meter to reduce the measurement error happened because of the entrapped air. In the next slide, I will show you some field trial result. It is the dark blue is the measurement results with a ProMass Q and the Endress Hauser meter, which has this multi-frequency technology enabled. And the second one is a meter without this multi-frequency technology. The bottom section is the gas void fraction, and then the vertical one is the flow measurement error. You can see in 2.5% of gas void fraction, the multi-frequency technology keeps the accuracy as it is expected, but if we look to the other meter, the measurement error can go up to more than 10%. And for the second difficulty, which is the flow regime, we speak about turbulent and laminar flows. Here, to define this turbulent and laminar inside the pipeline, this gentleman, Osborne Reynolds, created a dimensionless number, which we called a Reynolds number as today, and this number is a formula with some flow and liquid fluid parameters, and then by defining the Reynolds number, we can decide if the flow is laminar or if it is turbulent. The equation contains the inside diameter, mass flow rate, fluid density, and fluid viscosity. The last three are measurable parameters by the Coriolis meter, and the inside diameter is known. And by making extensive tests over a decade to identify and quantify this relationship of Reynolds number, fluid properties, and measurement performances, Endress Hauser has developed a patented algorithm to make the compensation of the flow regime effects on the measurement. So far this is the section about the theory, and now I will show you some real project examples to, let's say, highlight and to support my initial claim that Endress Hauser is much more than an instrument supplier. The first example is a least automatic custody transfer, a LACT unit. It is a very well-known code name for a measurement system which is measuring the amount of oil transferred to a production pipeline. This is a real example of a customer project in Latin America. This system has all the key points: basic sediment and water analyzer. Here you see the air eliminator. This is the diverter valve. If the water cut amount is above a certain limit, so-called 1%, you can say this diverter valve will quickly divert, fast-acting divert the flow from the pipeline to another tank, on a buffer tank. Here you see the Coriolis meter, the transmitters. At the back you don't see, but there is a small volume piston prover is installed on the system together with the control valve, skid frame, drains, and canopy. This is a complete LACT unit manufactured by Endress Hauser Engineering and Production. The second example is from a pipeline metering application. Here, this application has 3 streams, as you can see from the picture here. The specialty of this application that I want to highlight is that these 3 streams has different pressure classes. There is 2 streams with class 900 pressure rating, and there is 1 stream with class 150 pressure rating. But to optimize the operation and optimize the system, we make the pipe rack, you can see in the picture, and interconnecting piping, that both systems, class 900 and class 150, exactly same small volume piston prover. It is rated to class 900, of course, to be able to bear the pressure, the high pressure. But in this, as there is a shared system, we have to ensure that the high pressure liquid is not leaking to the low pressure parts, because they will damage. It is about their design pressure. Here we ensure the tightness of the system, and we also included safety valves, emergency shutdown valves in case of a leakage or misoperation, that the high pressure liquid does not go to the low pressure side of the skid. In this meter, then I mentioned the small volume piston prover. I would like to share you about some performances to say why, to give you an example why how we can do better than the normative asks. The ProMass meters are already calibrated with gravimetric factor calibration, which can be traceable up to the international standards, and delivered and installed in the custody metering system. Then there is a prover, which is a physical reference on the systems. And then when you prove a meter, the key performance indicator is the repeatability as per API. So the test is done under real conditions, with the process fluid. And the American Petroleum Institute gives the target. If you can ensure the repeatability of 0.05% in 3 runs, this means your system uncertainty is 0.027%, or you can do 3 runs, but of course you then have to do better 0.02%. What means better? I will show you a proving report. This is a real proving report made by the small volume piston prover and the Coriolis meter. As you can see here, while the repeatability requirement is 0.05%, we reach a repeatability of 0.0095. This is an excellent result and showing the performances of the Endress Hauser Coriolis meter. The next example, I will go for a ship offloading and vapor recovery system made for an LPG ship offloading application. Here you see the general arrangement drawing. If you go on site, you can see exactly the same with the equipment installed on site. Of course, the picture is taken in the middle of the installation, but we left the site as this, completely installed, insulated, and in operation. Next example will be a blending unit for LPG production. Here you see the blending of the propane and butane with the given percentages, 30-70% or 50-50%. And then once the LPG is blended, we install a custody transfer meter to make the physical measurement. Here you see the system installed on site. Then I will jump up to another LPG loading, but then this time it is also an unloading system, which is bidirectional. When you have an air eliminator installed on the system, the skid direction always is the same because air eliminators have one inlet and one outlet fixed. Therefore, to use it on both directions, we designed a system which with the pipes you see in the middle, which we can always keep the same direction of the liquid passing through the skid as same. Then the next example is different custody metering systems. You see this is the bidirectional system, but here you see 2 lines, one duty, one spare. You see here there is a single line metering circuit. And if you look at a closer look on this system, it is you see here together with the Coriolis meter, the control valve, the ball valves, on-off valves, and the air eliminator, all installed, cabled up to the junction box, ready to be put on site and make the interconnecting cabling to the customer system, and it is a ready operational unit. When I say on site, you can see these 2 systems, exactly the same 2 systems on their final operating positions. The next example I would like to speak about is the custody transfer ship loading unloading. Here we supply the meter and pressure temperature transmitters, but there is a specialty here. We allowed a spool piece for a master meter connection. What comes to the place of this spool piece? Here it comes the master meter. The meter is calibrated with hydrocarbons on the premium accuracy range. All the transmitter installed in this pipeline. Everything is connected to the junction box, and even we provided a quick connector once the master meter installed for operation, that it is easily connectable to the flow computing system to make the calculations. Here on the right hand side you see the duty meter and master meter installed side by side, and they are reading the same flow rate. This calibration has been witnessed by a notified body as per the European standard MID, Measurement Instrument Directives, and the calibration was certified, and then the notified body issued the certificate of conformity that the measurement system can be used in physical measurements within the European Union. I mentioned master metering. I will give an example also for the master metering, one more example. Master metering is an effective way of ensuring that the your duty meter is reading as accurately. Here what is done is the 2 meters read the same flow. The master meter has a special calibration, and it is not on the daily operation, so it is used on demand basis. You connect both meters tandem here like this, and then you check the flow reading of the Coriolis meter, you compare it to the flow reading of the master meter, and the difference is compensated with a so-called meter factor. The master metering with Coriolis meter has the same advantages of the meter itself: no wear tear, no rotative part, not pressure and temperature compensation for mass proving. It is also suitable for volume proving. It is compact and easy transport. You see some examples, some trolley examples, some heating jacket installation, or even it can be mounted on a frame on a skid. But if you have different locations, what happens? The transport of this is, maybe it is easily within a terminal, but if you have multiple terminals, what can Endress Hauser offer to you? Here you see the master metering skid, one 10-inch and one 6-inch flow meter. It is delivered as skid mounted and also installed on a truck. It has all the necessity auxiliaries like cranes to lift flexible piping to connect to the measurement skids. All cables are reeled on these bundles, here you see, and with all the wires it is ready for operation. What I mean by the operation, the truck is on site now, with the cranes provided, the flexibles are connected to the measurement system. All the cables are connected to the respective junction boxes, which is communicating with the flow computing system in the safe area, and you can make the test of the duty meters with real-life operational conditions. I hope I show you some examples on the claim that, say, Endress Hauser is much more than an instrument vendor. We can supply systems, flow metering systems. Now I will increase that, let's say, claim, and Endress Hauser can do more than a system supplier. What I mean with this, I will give an example of a turnkey project in Africa. This turnkey project is supply, design, manufacture, test, deliver, okay, and then install and then complete commission of the flow metering systems for edible oils and petroleum products. The project scope was 19 metering skids in 3 different harbors. These 3 different harbors has 3 control rooms, shelter installed with flow computer and control system, the MCC and such. The systems have all the common equipments and ancillaries like provers, interconnecting piping, oil slope tanks, seraphim systems, and etc. All the local works for the installation and commissioning has been done by the Endress Hauser team. And also we have a 3 years maintenance contract and extended warranty on the system. How it started? You see the jetty area here, the jetty number 1 and jetty number 2. Here in a more closer look, the jetties, the ships are docking on these jetties, and the product is transferred via the pipelines to their end destinations. Then a closer look of the area where metering and control systems will be installed. We take over this area as it is. We make the analysis of how we can utilize the required measurement on these areas, which led us to design a double deck skid system because the area is limited and the single deck will take too much space, which is not available. At the back, you see the control shelter I was mentioning, 2 rooms, one for electrical equipment and one for the operation personnel. Here I will show you, the scope of Endress Hauser was starting from this, the tie-in of the incoming piping, all the interconnecting pipes, all the site works, civil works, metering skids and such, and then all the interconnecting until the tie-out, also the, let's say, the physical doing of the tie-in and tie-out, and also the control room in here. So you see the drawings, here you see the design, and when it comes to the execution of the job, you see some examples. Here you see the start of the foundation works with all the drain, the piping, or all the cable ducts here to be installed. The second picture is almost at the finish of the civil works. Also this ladder to pass the interconnecting piping has been supplied. Then the metering skids has been manufactured in Europe and shipped to the country by sea-going containers. You see the unloading operation of the metering skids from the containers. You see the beginning phases of the installation. As I said, these are double deck systems, one for a product and the other one is for another product, the Coriolis meters, the valves, the sampling system here you can see to get the flow proportional sampling. And this is the picture of the finalized installation. You see the jetty from the first picture, you can remember the ship is docked and the measurement is there. And here you can also see the small volume piston prover is installed for testing one of the metering skids. By showing so, I am coming to the end of my presentation. I hope I am on time in the given 35 minutes. What is the message to take home? Endress Hauser is a reliable partner for you to design, supply, install, and commission of metering skids for liquid and gas hydrocarbons. We have worldwide presence, like the solution business unit I work for, is responsible for Europe, Central Asia, Africa. We have business units in Middle East. We have business units in Asia, in the Americas. We are next to you. We speak your language and we know your challenges and we know the market requirements or fiscal regulatory requirements. Endress Hauser is a strong, reliable and financially stable Swiss company, as Rob said in the beginning. And Endress Hauser has specialist and focused regional teams on custody transfer metering solutions to provide you best technical support from the conceptual design until the system operation. So I thank you very much for your attention and your time. And is there any questions?
Well, Alp, before we go to the questions, thank you very much for your great presentation, man. It was very interesting, especially the pictures, so you can actually see what happened and how it was constructed and made in various parts of the world. That was very good. We also like to point out to the handout on the right-hand side of your GoToPanel overview to download as well, if you're interested. No problem at all. And from that, I like to go to the questions. And one of the first questions I was asked was if there was a recording of this webinar. So people must have liked it now. And the answer is yes. There will be a recording made available on MS Streams where you can actually download the whole thing for internal education and presentation purposes. No problem at all. Then the first question, Alp. What is better in your opinion, a piston prover or a master meter verification?
It has two answers, Rob. One is an historical answer. The piston provers, when they replaced the big ball provers, they are accepted as an industry standard, and every document is referring to the piston, small volume piston provers. But more and more, we face the benefits of having a master meter in the proving operations, and it is also recently, at the last decade, is accepted by various institutions, fiscal authorities, and such. Of course, a master meter with a Coriolis flow meter requires less maintenance. It is more mobile. It reduces the need for filtration and such, and it is less delicate than a small volume piston prover. And let's say to maintain and operate a prover has a high Opex costs. The master meter is overcoming that cost structure.
Yeah, so it's depending a little bit. It's more tradition versus modern ways of looking at that stuff, and also probably the development of technology as such, and the reliability and the trustworthy of the measurement readings play a big factor in role here. Yeah.
Exactly, and I have to say, oil and gas is not the, let's say, quickly adapting industry. So
I
would say we have our beliefs and our ways to do, and also I have to say, from Pulse to Modbus, I had some difficulties.
I understand what you're saying. You're fully right. So let me go to the second question then. Can you use these systems also for LNG loading and offloading?
For sure, we can use the Coriolis meter, LNG loading and offloading. Also, the balance of gas can be measured by Coriolis. When it comes to LNG, of course, the system will look like a little bit different because of the low temperatures involved. So the necks will be higher, the valve stems shall be bigger and such. And also, for LNG, there is a quality parameter which we have to, let's say, take in account for energy calculation. Therefore, Endress Hauser also has the Raman analyzer, so the quality analyzer, which is perfectly fitting to LNG applications. So we can supply the complete measurement and the quality analyzing system for LNG.
So then you have one skid where you combine both the quantitative measurements, so the quantity and also the quality of the LNG as well, I guess, huh?
Correct.
Yeah, because you're not just buying the quantity, you also want to know how much the BTU value or the caloric value of the LNG that's being loaded and offloaded.
Exactly. It is a very important parameter for the fiscal measurement.
Yep, absolutely. Then let me come to the next question. Does the flow meter automatically compensate for the amount of entrained air?
It does. With the algorithm, with the shift in the frequency, it automatically compensates the amount of entrapped air, which is held inside the high viscous liquids. Correct.
Mm-hmm. So can you also get the information about the percentage of air in the liquid flow to the outside as well, Alp?
You can have the information of the inhomogeneous flow. The meter will tell you that the measurement is inhomogeneous, so there is air inside, and also it will give you an alarm when it is beyond the compensatable range.
Okay. So even if you have slugs and stuff like that, it tells you it has it. Okay.
Yeah.
Great. Then I'll go to the last question of today. This is for Marek, by the way. Which type of Coriolis meter is dedicated for gas measurements like ozone or helium? So I think, can you use Coriolis or some other technology for measuring ozone and helium?
The Coriolis meters is both approved for liquids and gas. The normative is different. So, for example, if you talk about Europe, the normative governing the liquid applications is MI 005, but for gases, it is MI 002. But Endress Hauser Coriolis meters, tell it PROMAS F, PROMAS Q, or PROMAS X, are both approved for the both normatives for liquid and for gas. It is basically the same meter and approved for both liquid and gas.
Yeah. Marek, I also encourage you to talk to your local Endress Hauser person, because you also need to know whether you want to measure it in volume or you want to measure it in mass. Do you want to measure it in liquid form or in gas form? So there is quite some stuff that makes the measurement principle, and depending on the kind of situation and the information that you want to get out of the meter as well.
Absolutely correct, Rob. And let's say gas is a kind of measurement which has broader limitations, I will say, than the liquid, and it has to be observed correctly. The conditions can kick in to decide for the physical measurement.
Yep, absolutely. Okay, so with this, if there are no other, or if you have another question, or whatever, 10 minutes from now you think, oh man, I wish I would have asked that Alp, please do not hesitate. Send either an email to Alp or myself. The way our emails are set up is very simple. It's first name, last name at endress.com. So in my case, rob.vermeulen@endress.com or alpcamci.endress.com. And we can answer those questions after the fact as well. So thank you very much for your participation. Next week we have same time, same place. We have a great webinar on water in oil and gas. So how to measure the quantity, how to measure the quality of water streams as well, both for steam generation and also for wastewater treatment as well. So if you're interested, please do not hesitate to sign up and be present. And with this, I like to thank you. Please stay safe, stay healthy, and I hope to see you next time as well. Thank you very much. Alp, you want to say something?
Thank you very much from also my side, and I can only say, as you said, Rob, stay safe, stay healthy, and thanks for the attention.
Thank you. And with this, I end the webinar.